Okay, so gold, this is on purpose, right? So you have 3 decimals. So you focus on that. So you want to have like 0, right? 0, 0, and then you put a 1 in for that 3rd decimal. That's how precise this thing is, to the nearest 1,000th of a gram. That's how precise this thing is. So it's a very precise instrument, right? And gold, if you ever sold gold, have you ever sold your jewelry? They measure it down to, that's probably how precise they are, and they pay you based on the weight, right? Because it's such, a lot of it is light. Uncertainty is half of that. So just divide it in half, and that's what you get. And then here we have a distance in meters, right? There are no decimals, so it's just to the nearest meter, right? You're focusing on that last number, and it's down to nearest meter, so 0.5 of a meter is the uncertainty. That's what you could be off by. So you're essentially saying 1,200 meters plus or minus half a meter. Okay, you're taking into account that limitation of the device. Here we have a 100-meter sprint, but we're looking at the time really, and the precision is down to the nearest 0.1 of a second. Like if you go down to the second decimal, that's what you focus on. The uncertainty is just half of it. The sprinter's time, including the uncertainty, so you would go 10.23 seconds, right, plus or minus the uncertainty. Right, that's the measurement with its uncertainty. So can I just say something? Quite often I will not make you go through this whole, the A and B. I will go straight to C. So the expectation is you find your precision, get your uncertainty, and then tack it onto your measurement. Given the uncertainty, that's what's the maximum and minimum times that could have taken for the sprinter to run that race. So 10.23 plus 0.005 and 10.23 minus 0.005. This is the max and this is the min. And you get 235, my bad. And this is 10.225 seconds. Right? Just use your calculator if you need to. Use your calculator. Do not hesitate to use it. Okay. What's the range, guys? Range, min or max minus min, right? I'm not going to do it here, but it could have been asked of you. And again, you should have had this already, and it's posted online. Okay, the key is posted online. Let's go to, I will do 2 questions only here. I will do question 8 and 10. That's all I'm going to do here. So after that, after yesterday and these 2 examples, you should have a pretty good idea how to do these guys. There's a piece of fabric which is 5.56 meters. You're cutting off a piece that is 2.6 meters long, 6.1 meters long. What is the length, including the uncertainty, of the remaining piece of fabric? Okay, I'm going to do this. Both have the same precision and uncertainty, right? Because both of them have 2 decimals. So the precision for both is 0.01 of a meter. Therefore, the uncertainty is 0.005 of a meter. Okay. Precision is the limitation of the device, and we can only assume that it's down to the nearest 100th of a meter based on the results. So when you're cutting off, what's happening? Adding or subtracting? You know this one. Of course, we're subtracting, right? So we go minus the 2.61 meter piece, which happens to have the same uncertainty. Not always will that be the case. So you subtract 6 minus 1, 5. I got to borrow, right? So this is 9, which this was a 4, right? So 2.95 meters. But what happens to the uncertainty? What do I do with the uncertainty every time? I add. Even though I subtracted the measurements because I'm cutting it off, you add. Okay, so this will be plus 0.01 of a meter, and there we go. So this is the length of the piece with the uncertainty remaining. Okay. And the reason is when you're combining different measurements, different items, their uncertainties keep on adding up, right? Because you could be cutting off longer or shorter every time by a little bit, so that messes with the total. So you keep combining that. Okay. And number 10. Okay. Jack works in shipping and receiving. He's given the weight of 4 pieces of a load to be 563 kilograms, right? So I need to do something here. I noticed that every single, or they don't all have the same precision and uncertainty. Okay, they don't all have the same precision. What's the precision for this one? 1 kilogram, yes. And the uncertainty therefore is 0.5 of a kilogram. Okay, what's the precision for this one? 0.1 kilogram. Uncertainty is 0.05 of a kilogram. Okay, next. What about this one? It's 5 kilograms. No, it's not 5 kilograms. We focus on that 5. It's 1 kilogram. Plus or minus. Oh, you don't need to do the plus or minus here. You just say that that's the uncertainty. Sorry, 0.5 there. And then this one, what's the precision for this one? 0.01, not 5. You focus on that 5, but that's not where what we write down. So this is 0.005 of a kilogram. So I've got the uncertainties of all those pieces laid out. And I'll give you a little cheat here. Yeah. You don't have to, but it would help if you make a mistake there and I still see you taking half of it. I would be a bit more understanding. Yeah. Like, let's say you write down 5 Kim J, right? And then you go 2.5. I'm like, okay, it's just a silly mistake, right? You understand what's happening. Okay, so I will do this. What is the total mass of the load combined uncertainty, right? So, and the combined uncertainty. So I'm going to do total mass. What are we doing? We're adding, right? Because we're putting those 4 pieces, we're loading those 4 pieces. So obviously we're adding. So I'm going to add this, and I'm going to add all the uncertainties here. Everything is in kilograms, so we're good. I need a calculator for this one because I'm guaranteeing you that I'm going to get it wrong. So this is 1,767.05 kilograms, plus or minus. You have to be careful here. Very careful. Decimal places here are going to be crucial. 0.5 plus 0.05 plus 0.5 again, plus 0.005, this one. And so that is 1.055 of a kilogram. Total mass with its combined uncertainty, and that's what it's supposed to be. So in this case, they all have different precisions and different uncertainties. There's 2 that have the same, right? So I will make a note here. Different, yeah. If the units are not the same, you got to do some converting. So if it's all in grams, then turn it, or if most of it is in grams, turn everything into grams. If most of it is into centimeters, turn all your meters to centimeters. I will never do inches I won't mix up inches and centimeters, for example. Different precisions here, right? This is a note. So you got to watch out for that. Let me just, yeah. Number 9. Okay. I think the wording is a little confusing, right? Well, I didn't write it, so I can't be blamed for it. Anyways, so there's a plumber first measures a pipe to be 2.05 meters in length. After she cuts off a 6 centimeter piece from the end, how long will the pipe be? So the idea is that, right, you have your piece of pipe, and that is originally 2.05 meters, but then you cut off, right? You cut off a 6 centimeter piece here off that. So the idea is, where should I do this? I will do it right here. 2.05 meters. What's my precision? 0.01. Oh, I don't like meters, so I'm going to go 205 centimeters. Just multiply this by 100 to get that into centimeters. Is that what threw you off? Okay. Because, yeah, that's going to make it a bit more challenging. It can be done, but I would not recommend you mixing up units. Yeah, so that's 205 centimeters. The precision is 1 centimeter. The uncertainty is 0.5 centimeters. And so minus, that's why I put this is in there, right? 1 meter is 100 centimeters, so minus 6 centimeters. The precision is still 1 centimeter. The uncertainty is 0.5 of a centimeter. So you subtract that, you get 199 centimeters plus or minus, you add these 1 centimeter. Does that make sense? Yeah, so I guess that's step to convert. If you see anything like this next to a question, hint, hint, right? Convert. I wouldn't just put that down for no reason. Okay. What I wanted to do before I give you the AC, so this AC, I will probably mark this one. I wanted to show you, so you're ready for tomorrow. Let me just see here where in the booklet I would have, maybe it's, oh yeah, right here. Can you go to page, there's no page number, but you got to go past 16. Past 16, you see this one. Just past 16, you see this worksheet with a bunch of pictures. Because no worksheet on this thing ever has anything like this on it, but you need to know. The province wants you to know. If you look at this thermometer here, what is the precision of this instrument? You go from 0 to 10, and then you jump another 10 and another 10, right? So the limitation of this device is that it's to the nearest 10 degrees. Does that make sense? This particular image tells you that your precision is 10 degrees Celsius. What's your uncertainty therefore? 5 degrees Celsius. So you're so used to your precision always being something 0.01, 0.001, but it's not always, especially when it's a diagram like this. My thermometer that I showed you for barbecuing, I have that at home now. But that one went up by 10 degrees Fahrenheit on the one end there. So you should see up, it will always be consistent, okay? I will never throw a curveball at you where it goes up by 10, all of a sudden by 15. Like it will be consistent, okay? What about this one here? The beaker. What's the precision of that one? It's not 100. 50? So some students just think, oh, 100, 200. No. Look at the markings. From here to here is 50, and then another 50, right? Oops, that one you can't see. But it's going up by 50, right? So the precision is 50 what? Yeah. Right, so don't worry about that, just look at the markings if there are any. This one is a little bit, yeah, like what, how come it starts at 100, right? I don't know why they would do that, to be honest, but this is like, I got it off the Google, right? And that's how they are, right? A lot of them. So this is ml, and so the uncertainty is 25 mLs, right? So I want you to, tomorrow I will actually throw some ACs, they will have a lot of this kind of stuff. And I'm pretty creative with instruments, okay? So all kinds of instruments that you'll see. This one, for example, this is a caliper to measure the diameter of very precise. What is the precision of this thing? Yeah, there's a decimal there. I don't know if you see it, but it's 0.01 of a what? The units are right there. It's small. Yeah, watch for the units because some of these are in inches. Okay, so always watch for the units. And then so half of that is, this is technically a question where I just gave you a number, right? But I'm also giving you the instrument, so you have to kind of think what's happening here, right? So there it goes. So if I give you the measurement with its uncertainty, if I ask you for that, if I ask you anything like this, you just take that measurement, plus or minus the uncertainty. You got it? I wanted to give you 2 ACs, but I'm just going to give you 1. What's that? The ruler? This one here? A? Let's do this one first. This one is, what's the precision on this one? You know what you do? You go from here to here. That's an inch. So just count 1, 2, 3, 4, 5, 6, 7, 8. 1/8 of an inch. That's what I would suggest you do. Yeah, smallest possible. This thing is limited to the nearest 1/8 of an inch. You're gonna have to round, right? Right. You divide that by 2. 1/8 of an inch. You can state it as a decimal. So 1 divided by 8 is 0.125 of an inch, and then you split that in half if you want. So it's 0.0625. Anybody in wood shop? What's half of 1/8 of an inch? 1/16. Are you sure you're not in woods, no? But you just know it? Okay. All right. You don't have to be in woods, I guess. It's okay if you don't convert it. Yeah. If you're okay with fractions, go for it. I don't mind fractions. Yeah. So what would you measure this thing? Which one is it closer to? What is 1/2 is actually what? 4/8, right? So this is then 5/8. So this is closer to 5/8. 5/8 of an inch plus or minus 1/16 of an inch. Or plus or minus this if you want to. That's fine. This is the one Kim J wanted me to do. What's the this one should be a giveaway. You got it? This is what? 1 millimeter, right? Like 1 millimeter. Even though you're seeing centimeters here, these markings are millimeters. You should or you can go 1/10 of a meter if you wanted to, which is 0.1 of a, sorry, 1/10 of a centimeter, right? Because if you count, there's 10 ticks between 1 centimeter and the other. So you could say it's 1/10 of a centimeter, which is 0.1 of a centimeter, which is really a millimeter. So if you're scratching your head, it's like, what? Like they're all the same. They would all be considered correct, right? They would all be considered correct. So the uncertainty, if you went with 1 millimeter, I just figure, you know what, you should have seen metric rulers by now, and you just know that the smallest on a ruler is usually a millimeter, right? This one, on the other hand, what's the precision of this? Yes, 0.5 centimeters, right? Because it goes, you see the centimeters are marked, but if you see that every centimeter is split in half, right? So you're going up by half a centimeter. Okay. That's it for this. Mhm. So I'll give you the shorter one because we don't have much time. So you can just close your book.